In this question, we're told that a circle with radius r lies only in the first quadrant and touches the x-axis and touches the y-axis, and that the line L has the equation 2x plus y equals 12. We need to show that the x-coordinates of a point of intersection of L with C satisfy this equation. So we need to sketch a diagram of our circle and the line. So we have the axes, and we're told that the circle intersects the y-axis and the x-axis and lies only in this first quadrant. So the centre will have a distance of the radius from the y-axis, so this will be r. It will have the same distance from the x-axis, so the centre of our circle will have coordinates r, r. And this allows us to find the equation of a circle. We'll have x minus r squared plus y minus r squared, and this will equal the radius squared. And now I'll expand out these brackets. So we get x squared minus 2xr plus r squared. We'll expand out this bracket. And we get y squared minus 2yr plus r squared. And this will equal the r squared. We can cancel this r squared with this one. And we need to write this y in terms of x. You can see that y is missing from this equation. So we can make y the subject of the equation of a line. So this will equal 12 minus 2x. And then we can substitute this expression for y into here and into here. So we'll have 12 minus 2x squared minus 2r lots of 12 minus 2x. And this will equal 0. We'll expand out this bracket and we get 144 minus 24x minus another 24x plus the 4x squared. So I'll substitute this into here. Now we'll expand out this bracket, so we get negative 24r, and the negative 2r times the negative 2x will be positive 4rx, and this will equal 0. Now we need to identify the like terms. So we've got our x squared terms, we've got the x terms, and we've got the constant terms. So 5x squared, we'll factor out the x from each of these x terms. We'll have a negative 2rx plus the 4rx, which gives us 2r, and then this negative 48. And for our constant terms, we've got the r squared minus the 24r plus the 144. And this will equal 0. This is what we were asked to show here. For part B, we're given also that L is a tangent to the curve. We need to find the two possible values of r given our answer as fully simplified thirds. So if this line is a tangent to this curve, then we know this will intersect the curve at one point. So we can use the discriminant. If it has one solution, then b squared will equal 4ac. This will be our b term, our a term, and our c term. So 2r minus 48 squared will equal 4 lots of a multiplied by the c. The r squared minus 24r plus 144. We'll expand out all the brackets. So we'll get 4r squared minus 192r plus 2,304. This is when we expand out this quadratic here. And this will equal the 20r squared minus 480r plus the 2,880. We need to make this quadratic equal 0, and this should be a 20r squared here. So we'll get 16r squared minus 288r plus 576. And you can see that we can divide everything by 16. So r squared minus 18r plus 36 will equal 0. Now in the question, we're told to leave r as fully simplified thirds. So we're going to complete the square. So we'll have r minus 9, half of this negative 18, squared. We'll complete the square, take away the 81, and we'll add back in the 36. So we'll get r minus 9 minus the 45 will equal 0. We'll move this negative 45 to the right-hand side. We'll take the square root, and when you square root the 45, this is the same as root 9 root 5, or 3 root 5. So r minus 9 will equal plus or minus 3 root 5. Then we'll move this negative 9 over to the right-hand side. So r will equal 9 plus or minus 3 root 5.